Hello, this is a live stream. We have simulated and tested our interface, and the goal of this today is to get a VDMA engine working where a microblaze can configure the frame that's outputted over our DVI. The first thing is I'm going to demonstrate running the DVI hardware, and then our next step is we need to put in an asynchronous FIFO into our IP, and then the step after that is to put in a VDMA with a microblaze and DDR. We're gonna have fun doing that. Go explore how this is going to work. Okay. So let's put in our. We're going to go put in the values that we need for this. Before we want FPGA timing. FPGA timing. We have that right here. Go ahead and copy that. And pound define, pound define, pound define, pound define. Okay. Go ahead and put these values in. This is our microblaze configuring the VGA timing, so we can potentially do different resolutions. We currently can't do that because we don't have a dynamic clock. But if we were to put a dynamic clock in there, then we could choose what resolution the device does, resolution and frame rate. So now we're just going to do this. So we set it to reset, we configure it, and then we let go of reset. So first let's program the FPGA. That's the right device, right wrapper. Go ahead and program it. Then I'll show you the purple screen that is outputted by the HDMI. That's currently what it's set to. And then we're going to launch this on hardware. Launch script is executed. Get Terra term going. We can actually the setup terminal receive. We want that on auto. Serial port. We want that on that right there. And it says it launched. So let's relaunch it. So we got the hello world, and then I'll go to my other monitor and set that up for HDMI. Okay, cool. As you can see, we got a beautiful purple screen at 1080p 60 Hz. We can't do anything at the moment with it, but what we're going to do is we're going to add VDMA with the DDR and the microblaze, so the microblaze can be able to change individual pixels within the frame that the VDMA is referencing. So let's go about doing that. Okay. So go about doing that. The first thing we need to do is we need to go through a diagram. We need to take our DVI stream right here, and we need to edit it and put an asynchronous FIFO, which is going to go from the operation clock, which is 142 megahertz, to the display, which is 149, which isn't a big difference, but I want to be able to always keep the processing clock at 142 megahertz, and then we can change. We want to make the display and the processing at different clock domains. So we have this component here. We can just remove that from the file, and then we're just going to go to our IP catalog and regenerate a FIFO. We're going to go to FIFO generator. We can't do built-in FIFO because it has to know the clock speed. So what's 2? 2 is first word fall through. And 1 is non-symmetric, different read and write widths. Since it's going to be a small FIFO, I think we can do distributed RAM. Let's do independent distributed RAM, synchronization stages, sure, we'll do 2. Native, yeah, let's make life easy. We could do AXI stream. What does AXI stream look like? Independent clock. No, let's do native. Native I can handle a lot better. Synchronization stages. And yes, I want to reset, right, read clock, yep. FIFO read, full the in write engine, empty read. And we might want to get that to a status bit if we ever try to do a read while it's empty. Or not care. I'm kind of on the preference of not caring. First word, we want first word, fall through. Because if you look at, right now, we have a read latency of 1. That's bad. I want a read latency of 0. I want to be able to read the same cycle that my read enable goes high. Okay, that's good. That's good. We don't need anything else. We're doing it 12 bits wide because that's the only thing we're doing. We don't need that much. Let's go down to 16. RAM 16. Status flags. We don't need any of this stuff. Data counts. We don't need any data counts. Yep, that is good. That is what we need. Let's just do this stream FIFO. And we can say, okay. Pretty sure we can generate it. Okay, so we'll build this. We're going to add this to our system as soon as it finishes building. We can look at the log for it. I don't think it should take too long. And then after that, we're going to add it, connect it up. We need to add the DDR, we need to add the VDMA, and we might have issues meeting timing. The goal is the VDMA is going to be operating at 142 megahertz. The DDR is going to be operating at 81 megahertz. The processor will be operating at 100 is what I think I currently have it set as. We'll see how the device meets timing. It may be a little bit tricky. I'll have to make sure there's no issues. Okay, so the finished synthesis. So let's go. And we go to IP sources, click here, go to installation template, go to the VHO file. That's what we want. So we can just copy and paste this component into this section. So we have that component, and then we're going to put this FIFO. So we're not going to use the stream template, so we can go ahead and remove that. And so go. So the stream clock, that's what we're going to have as the write clock. The read clock is going to be the pixel clock. And let's get the stream data. Key data. Yeah, that's what we care about. This is going to be what, 23 down to 12? Because we're not going to work. No, we're going to have to combine that. So, do we add a block here? Let's just go ahead and add a signal. Signal FIFO in standard logic vector 11 down to 0. Go here and say this is going to be 23 down to 20, concatenated with this value, starting at 19 down to 16 of 15 down to 12, 15, 14, 13, 12. And then one last time, and I think we're just going to do 7 down to 4. So, 4. That will give us a red, green, blue. Oh, sorry about that. And we'll put the FIFO in here, and the T valid. Oh no, FIFO in goes here. Oh, and then we'll need a write signal. So signal FIFO writes standard logic vector. That's a standard logic. FIFO write. FIFO write is going to equal valid and not FIFO full. So we'll need a signal for FIFO full. And to do, where's this? Ready. Where's the ready signal? T ready. T ready is going to equal not FIFO full. As long as the FIFO is not full, we can add more stuff to it. To do so, we need a pixel read. Out. FIFO, you don't have full. And the reset we want to be that. Read enable is, oh, apparently pixel in and then we're going to open the last one. So the pixel read's going out, which is the same as the active. And then we're going to have pixel in is the data that's being saved, FIFO full. If data is valid and FIFO is not false, we're going to write it. If FIFO is not full, we're going to tell the system ahead. Okay, so our asynchronous FIFO should be set up. Let us just run synthesis to see, make sure there's no issues. And then we're going to add that to our design with DDR and VDMA. And we're not doing any pixel packing, we're just going to do 32 bits wide. Okay. This runs through. Any messages? Care about info? Care about that? Um, that's interesting. Let's add those to the sensitivity list. Okay, let's rerun synthesis and we see if we get an error. Hopefully that will remove any latching that was happening that we weren't observing. Okay, that these are our current ones. Not an issue. Created. Okay, no issues so far. Oh, that's the out of context. I don't know, out of context one. Yeah, how about the in ones? Total, yeah, those aren't used. Those bits aren't used. Those bits aren't used. That's your design, not my fault. Okay. So I think we're good. So let's package this up. IP catalog, no, packet project. Where is my package screen? Um, Layout, default layout. Go open that guy. IP repo. Nope, nope, nope. Let's see if I edit this in IP package. Where'd it go? DCI. Okay, it's under that. Let's go find that project. Open. So we're gonna go DCI temp, DVI stream. Hmm. Um. Let me see how to open Bravado package IP packager. I mean, we could do and package this, package your current project. Yeah, already is an IP. We did the changes, so we may have to re-reference it. So if let's try to edit it again, and we'll have to overwrite it. All the files should still be there. I just want the IP. So we have this IP packager. So we want to let's add a source, add a file, PCI. We're going to go to IP repo, DVI stream. Do it now under source, FIFO generator. That's not the one we just did. Oh, may have to rebuild it. I hate it when this happens. So yeah, if we run synthesis, right, it won't have that design. So oh, that's what we removed that caused the packager to go bye-bye. Let's close this. We're going to edit an IP packager and not delete that thing. So we want that. So I'm going to package that IP catalog again. FIFO generator. Distributed RAM. It's gonna be 12. First word follow through. Yeah, that should be everything. What do we call it? What do we call it in the file? Stream FIFO. So let's go ahead and call it stream FIFO. And hit OK. We can skip that. We know it works. So we're going to merge files. What's that message there? That's okay. Merge changes, review, repackage. So go ahead and rerun, upgrade selected. Maybe we'll skip that. And let's go ahead, edit an IP packager again. I just want to make sure the edits were finalized. Sometimes it doesn't reference the IP properly. Okay, cool. This looks like it's happy. We'll find out in the long run. Okay. So now we need to add the DDR. So we need to add clock, right? We need a ref clock. So we have a ref clock 200. And let me figure out what the let's see, what was the second clock supposed to be for the DR? It's supposed to be 166, 166.667. So what you want to do here is make this the most important clock, then make this the 100. And this is going to be microblaze clock. This is going to be DVI. Oh, don't we need another processing clock as well? DVI clock. A lot of clock coming out of this guy. Microblaze, and then we have VDMA clock, which is going to be 142. Just running the same clock as that. So we're just gonna maybe run everything at the 148 clock. Make life easy. Yeah, we'll just try that for now. See how that goes. Weird. It's not updating. Clocking options. Give me a warning why I can't do that. Did we just change too much at once? I mean, let me call this let's just call this sys clock, right? This clock, it's going to be 166.667. And this is going to be DVI clock. Now let's see if I can add another clock output. Now we got those output clock. Why are we not adding more clocks, my friend? Weird, we might have to just delete this guy. He seems to be broken. So, delete. I will add my own clocking wizard. I don't know what you're connected to, but Okay. Clocking options. Output clock. No reset. So we're gonna have a sys clock. 166.667. We're having another output clock. We call it ref clock. It's gonna be running at 200. Can we add a third clock? And okay, see the diagram right here? It's not operating like I think it should. What in the world? Why is this thing acting this way? So we'll call you sys clock. We're just gonna do one clock at a time, I guess. No reset. Maybe I'll just reopen this because it's just acting so glitchy. Okay, so we're gonna save this. And we're gonna exit the block diagram because it has bad code. That out when we look at it later. So let's try this again. Output clocks. Okay, so now we're going to close Vivado because I don't trust that Vivado is actually operating correctly anymore. Weird. So yeah, let's try that again and see what's up with it. We may just start from scratch. If it doesn't work, we're creating a whole new project. This happens again. Output clock. Yeah, we're creating a whole new project. I have no clue what's up. New project. Never seen this glitch before. We're gonna call it DVI 002. We don't need any of that at the moment. Or it's ARTY. Yes. Okay, let's try this again, right? So a file we can add, let's add a source. We're gonna go back, we're gonna add a constraint file. So let's go to add, go to PCI, sources, constraints, new, that one. Finish. So first thing we're gonna do is try this again. Just the clock. Output clocks, let go of the reset. We're gonna have two output clocks. We're happy then. First one's gonna be 166.667. Next one's going to be 200 for a ref clock. We're gonna hit OK. Happy now. Go back and try to rename them. Output clocks. This is going to be DDR system. This one's going to be DDR ref. Okay, and then we'll do another clock manager based upon the DDR configuration. So let's see. Now let's drop down the DDR. So we're going to do the DDR SDRAM. Going to have a MIG device. And we're not going to use this. We're not going to use this. We're going to DDR system clock, and then we have a ref clock. Okay. And Now we're going to add, so we're going to do connection automation for the reset, system reset. Okay. Yeah, we'll see how we can do this. So I think, yeah, so next let's drop down the microblaze. Please want at least 64 kilobytes memory, enable peripherals, debug, cache. We can probably do 16 of cache. And clock connection, let's do a new clocking wizard. Yeah, new clocking wizard. The clocking in wizard. Cancel this clock wizard. Let's have no reset. The input clock is going to be global buffer? No buffer? I think so. It should already be buffered. Yeah, so let's just do an MB clock of 100. And our second clock, which is going to be our DVI clock of 148.5. 5. So microblaze is that one. Reset. Sure. And run connection. We want to do this as an AXI interconnect. Sure. You can pick whatever clock you want. Okay, what connection automation do we have next? Okay, now everything's happy. And we're going to add the fun part, the VDMA, direct video memory access. Let's see. Memory data width, read data width. We're just going to have a write channel. I'm going to set to 32. First length, I don't really care. That's fine. Frame buffers. Advanced. Okay, so that looks good. So, AXI light. It's gonna be the DVI clock. Reset clock wizard. Sure. Oh, we want a read channel. Sorry about that. We want a read channel. Let's try that again. Okay. Now let's drop down. So IP catalog, we need to add our repository, which is right here. Yep. And we want to, our DVI stream, we want to double click it, add to IP block. Run connection automation. Let's disconnect that pin and disconnect that pin and disconnect that pin, disconnect. Now when we go to this one, let's do it at the same pace as the UI clock. And then this one is the one running at the faster speed. Pixel clock is definitely going to be that one. And the slave, you can go ahead and run that at the system clock level. Control T, T, T. What did we call? Is it just clock out? Is that really what we called our thing? So we have a clock output as well. So these names, what we wanted them. Then do the clock output. Give another thing. Now we want to add a port. Add create port. A clock. It's an output. Clock. That's nasty. Pixel clock. There we go. What are we running connection automation for? Okay. Reset system clock. Okay, we got this whole thing set up now. Yay. Now let's validate it. Make sure it's all happy. Oh, gotta add a UART. That's important. So active VDM class must fulfill the below terms of clock briefing. The active light is less than equal to the M2A clock. So we're running this at 81. So here's what I think I'm gonna do. We just want to change the microblaze clock so it's equal. And save. So you know what I'm going to do? We're going to delete this guy and go in here and output clocks. So what we're going to do is we're going to put the DVI clock here. Call this clock out 2. Enter, uncheck it. This DVI clock. And we're going to make this 148.5. Save that. And run a connection automation. Microblaze clock, we want to run that off the UI clock. UI clock. UI clock. UI clock. UI clock. And validate. Okay. So he's saying this clock. Let's see. That's that clock. That clock is not right. So I'm going to do that. And what else is this clock going to? That is the only thing that clock runs to. Yeah, A3 across the board. Validate that. Oh, still need to add a UART. Okay. Yeah, so our system clock. So that's gone. Don't need that. And disconnect that. And where's the new reset? Apparently that's the reset we want. Weird. Okay, let's go ahead and add the UART. No, we want to use that. We want to use board. UART, Axie light. Double click this thing. Here we get to our favorite baud rate. Okay, on connection automation, we're going to run it to that system. Don't click this. I want minimal area because I don't know how we're going to be doing on our fabric space. Okay, one last thing. MIG's UART is active low and VDM is active high. So what you want to do, disconnect that pin, and disconnect that pin, want to disconnect that pin, and let this system automate that reset. Okay. I think it just added this whole reset block. Oh. Sorry, I'm working on a bid right now. Okay, check that. So validation's good. Let's create an HDL wrapper. Okay. Yeah, let's do synthesis and implementation. While we're doing that, I'm going to check this eBay auction I'm looking at on the side. And we're going to need to look at the VDMA implementation, figure out how to do that. It should be pretty straightforward. Uh, so I just had 3 bids on eBay, and they are all overturned at the last moment. That's kind of annoying. Go look at my. Oh, okay. Okay, so back to this. Let's go look at the VDMA software while we wait. Easiest way is just to go click here, product guide. It should open DocNav. May have to. Oh, here it goes. Okay, so I think we want to look at. There's like a use this, designing with this core, programming sequence. Here we go. So for MM2S, what are we doing here? We're doing MM2S. So right here, MMS, you're going to set the offset to start the channel running. Write a valid frame to address to the start address register 1 to N, where N equals the frame buffers. When VMDA is configured for address space greater than 32, each address write frame delay and a stride to the channel. Stride, horizontal size, vertical size, stride. Okay, we should look at the registers. So, okay, let's go look at the registers. Product specification, register space. Okay, here we go. Right, circular. Okay. Right here. So we're just gonna park it. Park pointer register. Frame, repeat. So I think we're going to want to park it on a specific frame. We're going to run it. Okay, reg index. Frame buffer is greater than any write or read access between. Okay. So we have a register index, park register pointer, read from store, write from store, reference, VDM version. When parked, count on buffer is referenced by this frame number. Okay, so this is just upper reg index. Okay. So read from store indicates the frame number being operated on by the MS channel. Okay, so I think we want to, so it's set at 0, so we just got to park it. Okay, version history. Yep. Okay, keep moving. Moving forward. Vertical size, boom. Horizontal size, boom. Stride. Stride indicates the number of address bytes between the first pixel of each video line. Okay, this is a stride. So this is basically the beginning of each thing. So we would want it to equal MSH size. Okay. And then we're going to start address. So offset 55C, we indicate the start address. And then just write some values to it. Maybe try all red or something to that address for that amount of bytes. Okay, interesting. I think we got it. We're still doing out context. Okay, so I'm probably going to leave the video stream here. We built it, we got it going. I'm going to play around with the clock so to make sure the clock and timing works before our next stream tomorrow. But then we should be able to do the software and get a microblaze to write a frame. So thank you for watching. That will be it for today. And have a good night. Bye.